access level modifiers, the concept. We covered the what, but I want to spend this tutorial digging into the why. I want to show a very clear example of why it might be important to have different visibility for methods and properties. So to demonstrate this, if you can scroll to the very bottom of the Scratch file, underneath the access level modifiers class, and we're going to make another new class. So we're going to make a fictional scorekeeper. We're going to make a system which other games can use, and they can use our code, our library, our class to handle the score. So we're going to make this scorekeeper class, and other games and other users are going to use this. Okay? So let's make the class scorekeeper, just like that, with a curly brace. I'm going to scroll down. This will have a very simple responsibility. It will keep a record of the scores for 2 players. It will allow us to say that one of the players has got a question correct, and when they do, it will increment the score. It will report back that that player got the question right, and showing what the current score is. And then when one player gets to 5 points, it will report that that person has won. Okay, so a very simple scorekeeper class that other games and other apps could use. So we'll have 2 properties, and for now we'll make everything public. So a public int, a number, and we'll make this player1 score, and we'll initialize this to 0. And we'll do another one for public int player2 score equals 0. So that's the 2 class variables, the fields. And what we'll do is we'll make a couple of methods to increment the score for each player. So we'll do a public method, public void, player1 correct answer, no parameters, and we'll make some brackets, and we'll just increment the score. We could do player1 score equals player1 score plus 1. We could do that. There's actually an easier way to do this, and that's player1 score plus plus. So that's the same thing. That's the same as saying player1 score equals player1 score plus 1. That would increment that by 1. And what we'll do is we'll do a system.out.println, and we'll add on the player1 and the player2 score. We'll do the player2 correct answer, and I'll make this player2 this new class. So all the way up to the Scratch file, and make a few line breaks. And let's now just test out, and then we'll do scorekeeper.player2 correct answer. So let's go ahead now and run this and see what the output is of our scorekeeper object. So run. Player 1 got 1 right, player 1 1, player 2 0, player 1 got 1 right, 2 0, player 2 got 1 right, 2 1. So we have a very simple class, a very simple system for keeping score in a game. Let's say public void check for winner, and curly brackets. So we'll say if player 1 score double equals fixed exclamation mark. And then we'll do else if 2 wins. So we have a very simple check for winner method. That will be good to call this from both the player 1 correct answer method and the player 2 correct answer method. So whichever player gets a question right, we will call the same check for winner method. I'm going to duplicate this a few times. I'll just do it 5 more times. 1, 2, 3, 4, 5. And we'll do player 1 correct answer, then player 2 again. So 3 2, then player 1 again, 4 2, 4 3, and then player 1 can win it in the end. Right, so let's run this to make sure that our check for winner 3 2, 4 2, 4 3, 5 3, and then player 1 wins. So our code works. What I'm actually going to do, I'm going to add a system.out above the scorekeeper. If I just close this, let's put a system.out. We'll print a blank line, and then let's duplicate that, and then we'll put a separator. We'll say start. So let's run that again to see how that looks. Okay, so we have a scorekeeper demo there. Good. Let's see how safe this code is. If I go to the top after my scorekeeper app, I'm going to comment out this fictional game we've played, and I'm going to do this: scorekeeper.player1 score equals 5. And then I'm going to do scorekeeper.get. Okay, so by making the player 1 score accessible, it's possible for some malicious code for some game to write the app in a way where it's possible to cheat. It's possible to manually set the player 1 score. And by having the check for winners method public, it's possible to check for a winner before even a single question has been answered. Okay, so it's not very robust, it's not very secure, our scorekeeper class. It's possible for anybody to use our code, but then immediately cheat with it. And we will say, this isn't good, exclamation effort. And we'll comment out this line as well. And then we'll say, with an arrow, while this maybe isn't as dangerous as manually changing the score, this isn't great, ... We don't need to check for a winner unless the score changes. This changes the score. And then we have another thing which it's not great, they shouldn't be able to check for winner. So let's now go down to our scorekeeper class, and let's improve our code. Let's make the player 1 score private, and the player 2 score private. We'll leave our player 1 correct answer, player 2 correct answer public, but we'll make our check for winner private. Okay, so now, if I just close the run pane, we've improved our code. If I go to the Scratch file, and I try and do scorekeeper.player1 score equals 5, not possible. It has private access. Back to these lines and do Control/. And our scorekeeper demo works even with the private fields. We're using them in our methods, not public methods. We're using the fields here, and we're using that private method, check for winner, but the check for winner method is called from inside the class, from inside the scorekeeper. Okay? So hopefully that shows a very simple but clear way in which the use of public and private has to bend all the fields from outside the class and make it private. And what you'll find is, as you're working with Android and developing apps, if it can see that you're only calling fields and only calling methods from inside the class and nowhere else, it will actively suggest you change things to private. In fact, we may have seen this once or twice already with some of our class properties, our fields. Okay? So try to make things private if possible. Be very clear about the things you want to make public. And just before we move on from access level modifiers, it'll be worthwhile to explain how Kotlin handles this. So if I go to our project and I go to Kotlin Foundations and our most recent one, our Functions Foundations lesson, I'm going to close the project pane, I'm going to close the side dialog. Okay? Kotlin handles public and private exactly like Java, so you can make something public, you can make something private, but it's gone with what it thinks is a sensible default. Often, public is the access level modifier that we use the most. Okay, this is arguable, it's not always the case, but often you find yourself making functions public, you make things available to other classes, and there might only be 1 or 2 inner methods that handle some of the utility, some of the behind-the-scenes calculations. Okay, so because public can often be the one we use the most, then by default, all functions are public. Don't confuse this with best practice. Best practice is, of course, to make things private if you possibly can, but if you don't specify anything, then the function will be public. And if I just take our greet function here, if you want to make it private, you add the word private. We're getting a warning because we're not inside a class, so the word private doesn't really make sense in Kotlin when it's not inside a class, okay? But that's how you would do it if you had a function or a method inside a class. Of course, there's the word protected as well, but again, it doesn't make sense outside of a class, okay? So by default, in Kotlin, things are public unless you specify otherwise. And that's just Kotlin trying to save us a bit of time, because in many Kotlin projects, public is the most common, okay? But our simple rule is, if you can, make something private. Only make things public if you absolutely have to. So that is access level modifiers, what they are, why they're important, and how they work by default in Kotlin. So let's get back now to our app and start developing the next screen.